we're just going to do some few examples looking at differentiating something with respect to a different letter. So for example, we don't always use x and y when we're describing functions, but we all know how to do something like the following. If you had y equals x squared, then the derivative, gradient function, dy by dx equals 2x. But what we say this is, this function here, this is the derivative of y with respect to x. But we come across functions where we don't use the letters y and x. So let's just do a few examples of how you differentiate functions like that, or functions of those sorts. So for example, if you had a function like this, capital A equals, I don't know, something like z squared plus 5z. Okay, so maybe this represents something like, I don't know, area with respect to this variable z. Then if you want to differentiate it, we differentiate a with respect to z. So treat, a as if it was the letter y and z as if it was the letter x, and just follow the same principle. So the power comes down here. So we differentiate each bit. So the power comes down, so we have a 2z, and this is just 1 times 5, so we have a plus 5, so to the power 0. So this is our derivative function for this, and we say this is the derivative of a with respect to z. Okay, just one more. Sometimes you get a mixture of letters and they may ask you to work out a particular derivative. So let's say we had this s equals d plus ut plus a half at squared. My handwriting's a bit poor here, but okay, we've got a mixture of letters. But let's say, I don't know, in the question itself, in the exam question, they said work out ds by dt, basically the derivative of s with respect to t. So basically, even though we've got a mixture of letters u, d, a and t, keep all the other letters fixed and differentiate it with respect to t. So let's start off with the first function t. This first bit of the function, d. This has no letter t next to it, so it just disappears. So I'll strike a line through it. But this bit has a t next to it. Okay, the t has a power 1. It multiplies the thing in front and then reduces by 1. So we'll just have a u here. So we've got a u. This bit, we have a half a times t squared. The 2 multiplies this. Well, think about what 2 times a half a would be. That would just be a. And then the power reduces by 1, so we have a t. So we've got u plus at. So this is the derivative of s with respect to t, is just u plus at. So even though we've got a mixture of letters, our variable that we're concentrating on is the letter t here. So we just differentiate all the bits that's got a t next to it, and then anything that doesn't have a t next to it just disappears. So this is like differentiating a function with respect to a different letter or variable. Okay, so we're going to be doing a lot of that in the next few clips.